want to know all your secrets.
Where are the brownies?
Where are the brownies? Cole, get the brownies.
Oh, yeah.
Okay, so we have brownies because you earned the brownie points. Now, typically I would just make the brownies, but yesterday I ordered from Walmart to pick up at 9 a.m. and then they call me and they're like, so like a freezer and a fridge are down, so we can give you your order, but none of your cold stuff if you want. I was like, no, I'm gonna just make a separate order. So I ordered from Amazon, but it didn't get here until 9 p.m. So I ordered Amazon brownies. Ethan, it says there are no nuts, but it is shared equipment. So, all right, here's brownies. Oh, let me grab you some napkins.
Daily rep standard. Probably only gonna have one. You don't want.
How many there are? I could probably have two.
You need to be careful.
Oh, no.
Everybody else needs to be careful of me.
Oh, give me one.
Make sure you're
No.
not touching each other's
It's
food.
the people
What
that-
do you want?
Okay.
Brookie?
Yes, you guys earned them.
I want a brookie. Don't touch it with your hands.
I am the world's worst typist, so you're good to go.
Right, almost.
Oh, by the way, Miss Daddy, I found the brownie points. This week's lab is actually.
It's 13. One of the juniors caught it first.
Oh, but now that's in the junior area,
That's
not in the
close.
senior.
Labs are shared.
You're not a
That's
senior.
disgusting.
There was a typo in the
In
test.
2 days,
but that's okay.
Somebody caught it. Mhm.
Probably.
They were like
I'm
two.
not smart enough.
Mhm.
So.
Oh, yeah.
Was it bet? I don't know.
Honestly, rookies? These are only like four.
I am literally the world's worst typist, so
They're all right.
you're gonna find lots of them.
These are not that good.
Yours are better, Miss Danny.
Thanks.
Yeah.
They're passable, but hey, there's something. All right, first note, important. I changed your homework assignment this week. It's not what's in your book.
What?
What's that thing making noise again? I'm gonna turn that down. It's not what's in your book because, I mean, your binder, because what's in your binder actually doesn't relate to the part of the, what's this thing making noise? To the part of the lesson that you're reading this week. So it doesn't make sense for you to do it. Instead, I have put in the Teachers portal for you guys a video, and it's one of those crash course ones.
Wow.
And so,
Yeah, he's underwater.
Yes.
yeah, the blonde dude, not Professor Dave.
Oh, never mind.
Anyway, it's the crash course video, but it
Ozzy, leave it. Hey.
the first half of it is really what you need to focus on. You may take notes. Take all the notes you want, and then why is that thing still making noise? And then I don't know why it does that sometimes. And then at the end of the sorry, take notes, and then when you come to class next week, I'm gonna ask you questions for you to answer in writing. Not like a quiz, because it's still gonna be a homework assignment.
Last week homework day.
Yeah.
So it said in the front of the page and on the email reception 4.3.
Yeah, I got that.
Okay, I was
It was
making
supposed
sure.
to be
'Cause
9.
I didn't know which one to do, so I did the one with the names rather than the four.
Yeah, it's not another one
The
there.
joke, the joke is it's not true at all.
Why did you share it?
That was complicated.
Now I don't feel like
I know, but
I
you
hate
Gotta make it sound like
Oh,
Sure, yeah, good
You're
job.
in so much better shape than both of you.
I'm sorry.
I couldn't believe it.
Oh,
No,
no.
maybe it
Be there.
What was that?
What noise was
I
that?
might
It was the sound that
I'm
came from
gonna
the
need a
washing
tape
window.
and a new full Kevlar, full.
What the
Yeah,
heck?
I really got.
Bro, I thought we got the dice roll out of the attic.
Riot shield.
You're going to need a tape. You're gonna need an open string device.
No, I think it's a attack helicopter would be easier because I think she can like rip the tank's metal apart. I think it would have.
What are y'all talking
Oh,
about?
what the heck?
It's a private conversation, okay, about how his sister.
Me and
Why is there a helicopter involved in this?
I'm just gonna
Because safety reasons.
Because apparently she's scary. Yeah, she's
Hey, guys, you want us to make really?
She makes us fearful.
I swear to God. Stop it.
Wow, little baby.
Okay, Michael, I'm standing here, so I'm gonna give it a drip, okay?
Okay.
Down, that's loud.
Oh, you're something.
Rinsing.
I have one, I will.
All right.
Abby's hurt me before.
So your homework assignment is in your portal,
Oh, my.
and it is also in your it'll be in your email too. So you're gonna watch the video, watch the video, take notes, because your notes, you'll be able to use your notes in class next week to answer the questions I'm gonna toss at you. Okay, so this is more along the lines of
Nice.
how good are you at taking notes like as if it were a lecture, so that you could use them should a quiz appear. I'm not treating it like a quiz, but you may walk into a college class one day where somebody does the exact same thing. So it's good for you to practice that skill. Watch the video, take as many notes as you can, so that when you get to class, you'll be able to hopefully answer the questions. All right, Shannon is out today because her sister is sick. Mm-hmm.
Can I borrow a pen from you?
Yeah, there should be some in that basket.
Never mind. You can-
You're good? All right, so did anybody find this difficult, stoichiometry? I know a couple of you said. Okay, so it's actually easier than it looks. The lab that's week after next is the tricky one. So first off, this nerdy t-shirt that I've had since before I taught chemistry. Without stoichiometry, there would be no cupcakes. I wore this to my doctor's office once, and we were in the middle of a conversation, and then he just started pointing at me and he burst out laughing like a little girl. I mean, like he was cracking up. And I was like, what? He's like, your shirt is the best shirt ever. Science nerds.
Will there still be cookies if we didn't have it? Or would they?
No, there would be no cookies. There would be no brownies.
You can just mix random amounts together.
So stoichiometry, if you just think about it like a recipe, it's really not that difficult. So for example, if you need a tablespoon of peanut butter, a tablespoon of jelly, and 2 pieces of bread to make a peanut butter and jelly sandwich, what do you need to, how many tablespoons of peanut butter do you need to make 3 peanut butter and jelly sandwiches?
3.
Right, and if you've got 3 tablespoons of peanut butter, how many slices of bread do you need?
6.
That's it. It's just doubling recipes, dividing recipes, that's all it is.
1.
Why did the chicken fry?
That's a lie.
How about half?
No.
All right, so I used like cartoon food, so to hopefully not make you too hungry.
Health and safety reasons.
Not for me, no.
Public service.
All right, so calculating quantities in reactions. How do we do this? Now, the lab we have next week is our last week before we're off for a week for Thanksgiving, right? So next week's lab is a demo lab. You got nothing to do except observe, maybe write some notes, pay attention. We're gonna build 2 smoking apparatuses, and we are going to make them smoke cigarettes, one with a filter, one without, and then we're gonna check on the solids that they produce. So it,
Do they get to pick the cigarettes when they smoke?
I have already bought at least, I bought the unfiltered, the filtered pack.
Standing so
It
close.
says Shannon's here, but I don't see Shannon.
No.
Oh, that's
for your
bizarre.
information, they're not Marlboros.
No, they are
Only
the cheapest cigarettes I could find. I actually stood and looked at the lady at Publix behind the counter, and I was like, hi, I need your cheapest, nastiest cigarettes. And she just looked at me. I was like, oh, I'm not smoking them. I got a machine that's going to smoke them, but I need your nastiest. So she actually went back there and found these things. It was called like 350 Blues. I've never even heard of them. So they're total junk, which is what we want. So, oh, you've heard of them? You've actually heard of them? I mean, even the label, it looks like a 5-year-old made it on PowerPoint. It's pretty impressive. Like, so
Aren't they called the cancer ones?
my mother suggested just tearing the filters off to make the unfiltered cigarettes, but we need to do some measuring. So I'm going to have to go find maybe like some Lucy somewhere or something. But anyway, so there's that. And then check the homework thing. Those are my major notes. So moving on to this. So balanced equations show proportions. It's all about proportions. It's all about like if you've ever doubled a recipe or divided a recipe, it's the same concept. So the whole idea behind stoichiometry is that it's the branch of chemistry that deals with quantities of substances in chemical reactions. Quantities. So just so you know, the stoichiometry word, because that's a weird word, comes from the Greek word, I believe that's stoichion. I don't do Greek too often, only once or twice a year. And which means element, and then metron, which of course means measurement. So when you get stoichiometry together, you get measuring elements. So there are 5 laws of stoichiometry, and these are the laws of chemical combination, and I'll give you what the 5 are. Now, your book didn't spend too much time on the 5 laws and like who came up with them and stuff, so I've got a little backstory for you today, and I've got some, hopefully what's a really fascinating story about Antoine Lavoisier. Y'all read about Antoine Lavoisier?
All the time.
Okay, so yeah, he's cool. He was a cool dude, but truthfully, his wife was even cooler. And she's one of those women back in the early days of science who does not get the credit she's due. So,
Every woman ever.
getting better, but you know, like Rosalind Franklin for decades, right? All right, so here are your main 5 laws. You've got conservation of mass, constant proportion, multiple proportion, reciprocal proportion, and gaseous volumes. These are the big laws that are going to apply to the whole concept of stoichiometry. So here's what they are. So your law of conservation of mass. So I gave these guys like fancy frames and stuff. So this is Antoine Lavoisier. He is the dude. He is the father of chemistry. Dude did a lot, like a whole lot. And we'll learn a little more about him because I have a little blurb on him at the end. So the law was enunciated by Antoine Laurent de Lavoisier in 1789. That's a way back. So according to this law, there's no detectable change in mass during a chemical reaction in a closed system. We know this, right? Prior to him, the belief was that when a chemical reaction occurred, new atoms could appear on the other side. Just completely new elements might show up. They actually believe they're, you know, this is when they had the elements of like earth, fire, water, that kind of thing. So he was really the guy that he named oxygen, he named hydrogen, like the guy. Actually, there's well, I'll wait till I won't ruin the surprise for you. So the total mass of a reactant undergoing a chemical reaction is always equal to the total mass of the product, right? We know that. So if you have substance A react with substance B and you give products C and D, and if the mass of A and B react to C, then C and D, same thing we've been studying for a while. We understand that, conservation of mass. So it gives you a mathematical example there and shows you that the numbers are the same all the way across and it's balanced, ta-da. Now this one may be a little newer. So the next one here, this is the law of constant proportion. So here's another, this guy looks a little more stuffy than Lavoisier.
Okay.
I also think he probably lived a whole lot longer. So, which we'll get to. So this was William Prout, and this is 1799, so 10 years later. And this law states that a pure chemical compound always contains the same elements combined together in the same proportion by weight, whatever the method of its preparation or whatever its source might be. So this is the dude who was like, all right, cool. We got a compound here. This compound is water. It's always going to have the ratio of H2O. It could be 3 or 4 or 5 of those H2Os, but it's always H2O. That's what he's saying. So let a compound AB is prepared by 2 methods. The first method, it says let A, and then let B, and then you get B to form A, and similarly X, all these little examples here. We don't really need to go through them too much, but I'll leave them up. So according to the law of constant or definite proportion, the ratio AB is equal to XY if you look at the above two examples. So if you've got, I think they're using GM for gram there, which isn't usually done, but in some places it still is. And then example, preparation of carbon dioxide by the action of hydrochloric acid and calcium carbonate is shown below. And we're actually going to be using calcium carbonate and hydrochloric acid in our lab, not the next one, but the one after. And that one should actually be pretty fun. So in these balanced chemical equations, the gas carbon dioxide always contains the elements carbon and oxygen combining together, 12 parts by weight of carbon, 32 parts by weight of oxygen, always going to be that way. And it gives you that ratio, 12 to 32. So now we have this fellow. Ooh, look at this fellow.
Oh, man.
Oh no,
I'm so scared.
he gets all the ladies.
You got
And so this was John Dalton. Y'all know John Dalton, right? John Dalton with atomic theory, John Dalton, 1803. So get this, you got Lavoisier recognizing that you've always got conservation of mass. And then a fair amount of years later, that was 1789. Now it's all the way 1803 before we get the dude who pretty much comes up with a model for an atom, like the first somewhat usable theory for an atom. Remember, most of the things in his theory were right, but there were a couple that we look back on and go, no, you can split a nucleus, that kind of thing. So yeah, you don't want to, but you can.
Don't do it. No, it's not good.
So
Nuke.
the law of multiple proportions.
Don't nuking people.
So the idea with the law of multiple proportions is that if 2 elements combine to give 2 or more different chemical compounds, then the weight of one of the elements, which combined with the fixed weight of the other, always show the numerical ratio to one another. So that's kind of like blah, blah, blah. But if you look at it, there's your example. You got 2HO2 is 2H2O, 2 parts by weight hydrogen, 16 parts by weight oxygen, 1 part water molecule. So it's the same thing. This is basic stoichiometry here. This is the whole idea that, you know, if you're doubling your recipe or dividing your recipe, you're just keeping the ratios the same. It's all about ratios. Do you guys feel like you know a lot about ratios?
Yeah.
Or, so let's do it this way. If the ratio of, let's see, if the ratio of men on a college campus, men to women, is 2 to 5, there's a lot more women on that college campus, which is kind of becoming the case. Which campus is this, right? All right, and then say that the ratio of men's rooms to women's rooms is 1 to 1. Who's gonna have a harder time getting into the bathroom? Yeah, because there are more women than there are bathrooms compared to the ratio for men in bathrooms, right? Okay, same kind of idea.
Well, we hold it more than men do.
Yeah.
Our bladders are way better.
Mhm.
Thanks, guys.
A lot of things are better. So this guy, he looks kind of snooty. I like his collar. So this is Jeremy Richter. Jeremy Richter, right? In 1792, so ahead of Dalton. But this is the law of reciprocal proportions. So this says that 2 or more elements which combine separately with fixed weight of with the fixed weight of another element are the same or simple multiples of the weights of the elements when they combine among themselves, blah, blah, blah. So for example, you got carbon and oxygen combined separately with hydrogen, and they produce corresponding amounts of methane and water. So if you look right there, it gives you the example. You've got your hydrogen and your carbon and you got methane. And then you've got the same amount of hydrogen, but with oxygen, and you get something different. So in the given balanced equation, 12 parts of carbon, if you had 12 parts of carbon, and 32 parts by weight of oxygen combined separately with the fixed weight, 4 parts by weight of hydrogen to produce methane and water respectively. So those are the basic rules. And then you got the last one. And this guy, I like him too. He's got a great smoking jacket or whatever that is. I love finding pictures of these old dudes.
Is that an ascot?
So we're going to talk about this guy later. This is the guy that deals with gases. This is Joseph Louis Gay-Lussac in 1808. Now, there's actually a law in chemistry that you will use. It's a gas law, and it's Gay-Lussac's law. And Gay-Lussac's law is pretty common and will be used. God bless him. His name was Gay-Lussac. And of course, we're Americans. We say Gay-Lussac, but Gay-Lussac, but Gay-Lussac's law, right? And according to this law, when gases react to give products under the same condition of temperature and pressure, they react in simple whole number ratio by volumes. This has to do with temperature and pressure staying the same. And when you get to this law, you'll see the acronym STP a lot, as standard temperature pressure. Not the stuff that goes with car racing, STP, but standard temperature and pressure. Yeah, there you go. So it's showing you right here that if you have a certain volume of hydrogen and a certain volume of chlorine, then you've got one molecule and another that combine to form a new compound, and the ratio there is 1, 1, and 2. Does that make sense? 1, 1, and 2?
Yeah.
And if you look at the one below it, it's 1, 3, and 2. Now, this is important because it's the ratios that you're going to use when you get into stoichiometry. It's all about ratios. There's a lot of, well, we'll get to it in a minute, but there's a lot of what's the ratio of this divided by the ratio of that. And sometimes it's just 1 and 1, and your answer doesn't change all that much. So moving on from that, those old dudes, here's where we're talking about mole ratio being the key. You've got to have your mole ratio correct. See my moles? The mole ratio is yeah. These ratios are all the same, but you got to have your moles. So for example, converting between amounts in moles. So you take your amount of your known and you take the moles of that. That's the amount. You're going to do the amount in moles. So the amount of the known, then you're going to use your mole ratio. And then you're going to which is your moles of known and your moles of unknown. And then your amount of your unknown ends up over here. So if you're trying to find your unknown, all you need is the known and the ratio. That's all you need. And you'll find your unknown. So there you go. Here's your sandwich analogy.
14.
You need 2 pieces of bread plus a piece of cheese to make a very flimsy grilled cheese with only 1 piece of cheese in it. Who does that?
Oh.
That ain't right. If you're gonna do it, I mean, do it.
How many slices?
Actually, the 2 things that you.
No.
So to make 7, you're gonna need 14 pieces of bread.
Wow, even your eyebrow looks amazing in the picture.
That was not needed.
Wait, honestly.
Absolutely not. That
Mhm.
was not needed.
Oh my gosh.
So if Ethan has 2 eyebrows, and no, sorry.
Fabulous.
Mhm.
You're welcome.
So this is a helpful diagram.
Hey, Ethan.
This one's called, all right, you good? This one's called the mole island diagram, because look, the little moles there are an island. And it shows you how to go from mass through moles. They're an island, they're in the middle. Everything's coming to both of them, the mole island, see?
Okay.
Mole island.
Did the 2 halves decide?
Always convert to moles whenever you are trying to figure out what to do. Moles are always a good way to go. So if you want to go from mass to particles, or from volume to mass, or from particles to volume, you just float across the little mole island in the middle and it will get you there. This is a good one. And you can look up mole island diagram. There's about 900 versions of it online. I mean, it's a pretty common thing. And you can stick it right there in your binder as something to use when you get stuck or need it. So limiting reactants. So your lab asked about your limiting reactant. You can call it limiting reactant, you can call it limiting agent. It's the same thing, okay? So your lab asked about your limiting reactant. What was the limiting reactant in your lab? Did anybody get that far? Figure it out?
The lab?
Mm-hmm. And we just did. Typically, there is a limited amount of one thing and an excess of another.
Oh, so it's the sodium.
Mm-hmm.
Was it sodium chloride?
Mm-hmm. Yeah, because you don't know how much of it you have, right?
Well, it was 16 milliliters.
Yeah, I mean, you knew how many milliliters, but you don't know how much sodium carbonate was in that aqueous solution.
Yeah, cool.
We don't know if it was 50% water, 50%.
Y'all didn't-
You could very easily,
You're both listening to music.
so you could very easily find out exactly how much strontium chloride you had, because you knew the molarity of the solution. If you knew the molarity of the solution and the volume, you're good. You can find out exactly how much strontium chloride is dissolved in that water, but you don't know with the strontium carbonate. So it's limiting. And you can put in as much sodium chloride as you want to get it to react. And then you should be able at the end to go ahead and get the mass and figure it all out. Now, we talked about what things could be dissolved when we did the little drippy rinse at the end. Actually, too, another thing would be excess strontium chloride. So you'd be worried about sodium chloride and you'd be worried about excess strontium chloride, because if you just kept pouring it in, you'd have extra, right? So your limiting reactant is the one that limits the amount of product that can form. You can pour in all the strontium chloride on Earth and you're only going to get precipitate for the amount of sodium carbonate you had, right? So it limits it. And it also would, try again, Oz.
You got this.
There you go.
It also will determine what we would call the theoretical yield. So your theoretical yield is, how much can I get out of this if this reaction goes perfectly? It's your mathematical number. Are you ever going to get, do you think, a full theoretical yield delivered, or probably not? You're going to miss something. I mean, just in the that's why we rinsed everything and ran it through again and again, because we're trying to get as close as possible, but something's going to get left behind. Your excess reactant, you're going to have some left over after the reaction stops. So you were pouring a lot of excess strontium chloride through that filter. I mean, because that liquid that was left behind, you had the sodium chloride, but you also had water, and you probably also had some sodium chloride it's from strontium chloride, sorry, that hadn't reacted. So you need to pour that through and then rinse it off. Oh, he plays like that, and he will bite hard when he plays. Like he's playing, but his teeth are stronger than they look for a little tiny dog. So here's another example. And this is brownies, because I'd hoped to make brownies, but All right, so if you had 2 boxes and 12 eggs, your boxes are your limiting reactant. You got enough eggs to make Well, if it takes 2 eggs by the picture here, I'm gonna guess it takes 2 eggs per box. How, if the brownies weren't limited, how many boxes of brownies could you go through there?
6.
Just 6 more, yeah, sorry, yeah, 6. So, but you're limited down to 12, right? I mean, sorry, down to 2 because you have only 2 boxes. Yeah, blah, blah, blah. Can't speak English today. I really can't. One of those days. So your theoretical yield, again, this is the amount of product produced if the reaction works perfectly. And it's the amount predicted by your calculation. It's not going to be what you get. Hopefully you'll get close. Your actual yield, oh, and I will say your theoretical yield, obviously a lot of that is going to be determined by how granular your measurements can get. Like a lot of you guys were going, okay, well, I have to go to the hundredths place on the decimal with my balance here, but I don't see those on here. You have to kind of eyeball it and guess with our balances. But if you have the really high end scales that they have in like big chem labs, you go and clever it and everything, like put a lid on it, and it's this tiny super sensitive scale. Like if you lift the lid, it'll start to move because just the pressure of the air moving it catches. They're super sensitive. So your actual yield is what you get. And that's what we got today, an actual yield, right? So it's the amount of product actually produced by a reaction. And you have to determine it with an experiment. It's the only way to determine it. Theoretically, it's math. Actually, it's an experiment. And it's going to be less than your theoretical yield. This making sense?
Yeah.
Obviously, this part's easy, right? And then your percentage yield. Okay, so this one, So this describes the efficiency of your reaction. So if we're talking about theoretical yield, that's 100%. But if we're talking about actual yield, it's going to be less. So if your reaction is efficient and you've done a good job, you're going to get closer and closer. So obviously how you find that is part over whole, right? Because if you had part over whole, so if say you're supposed to get 100 grams of whatever your product is, okay, and you get 90, what percentage is your 90%, right? So, and how about if it was 50? If you're supposed to get 50 grams and you got 25,
50%.
only 50% efficient, right? That's not good. 50% is really not good. All right, so your book had a little bit on, there we go. Your book had a little bit on stoichiometry and cars. Really, I think it was just because it was interesting. Really nothing of,
Is that Camaro? You.
it's a Corvette.
Oh, that's better. That's better.
That's much better.
That's better.
Really nothing of major importance as far as what you'll be accountable for in this class, but it's the idea of, hey, look, real life use of these things. So stoichiometry is needed in pollution control, engine efficiency, airbags. In the video that I'm sending you guys for homework, the crash course dude talks about hand warmers. You know the hand warmers that you shake? Have you ever used those? You shake them and they get warm. I used them to show the other kids about how it was chemical change because it's creating heat. So they've got some compound inside that's reacting to the oxygen when you shake it around. It's usually like iron filings and some other stuff, weirdly enough. And but they've used stoichiometry because if they didn't, what if you took it and you shook it and suddenly it like burned your skin off because it was way hot? Like you need it to be just right. So that's the kind of real life application for that sort of thing, right? You don't want it to be too much one way or the other way. You got to keep ratios and proportions working smoothly. Right. So, all right, for notes, we'll look at your notes and then we'll look at your homework and we'll go over and make sure everybody understands it. Now, the other guys, we did this morning a escape room. It was like balancing chemical equations, virtual escape room. And I'm going to put it in the email for you all because it was really fun and we didn't get out. We didn't have time. We were still stuck in the escape room. But I'll add that if you guys want to do it. It does help. I think, leave it. Leave it.
He's terrifying. Yeah.
Oh yeah, listen to that growl.
Horrible.
He's, yeah, big dog.
He's like,
Ozzy, come. Ozzy, come.
I will kill you.
yeah,
I will actually.
Come.
he was like,
Good boy.
oh.
You come here. You come here. Are you scaring away everybody? Oh my goodness, you're so frightening.
Look at him.
You're so frightening.
Ozzy.
All right, so all stoichiometric calculations involving equations use what kind of ratios? Molar ratios, there you go. Use molar ratios, and
Yep.
we try to keep them whole number, at least at this point.
Yeah.
So when solving stoichiometric problems, you must what? Cole, yes, balance it. Okay, you have to balance it because then you can't, if you don't have the coefficients, you can't get the molar ratio, and you need the molar ratio to do the work, right? So balanced equations give the what? Number of moles. Relative. Okay, what does that mean? What does that statement mean?
Balance equations with the relative number of-
It tells you how many moles of this are required. Are,
What do you
gives
ask?
you
Yeah.
how many moles of this
Mm-hmm.
are gotten for this many moles of that.
Right, it's relative, exactly. It's like, you ever had anybody say something like, oh my gosh, I remember the kids would say, like when they were little or something, you'd see on TV, so-and-so sold such and such big company for $30 million. And they're like, oh my gosh, that's so much money. But it kind of depends, right? It's relative. Is $30 million expensive for Home Depot? Like if somebody bought Home Depot for $30 million, that would be a steal, right? An absolute steal. But if somebody gave me $30 million, I would never see, I love you, but I would never see any of you again. Like I'd be gone, right? So I mean,
Including you, Cole.
including Cole, yeah.
Especially-
Bye-bye. I'd just go get a little island full of dachshunds and I'd be happy.
No sharing the wealth.
As long as it's in the
All
will,
hers.
it's cool.
So yeah, so relative, it's all about relativity. And you know, it's comparing one thing to another. Like in that case, we would compare $30 million to your income versus the cost of Home Depot. It's comparing to another. So it's a relative number of moles. So what's number 4? Who's got 4? Abby. Okay, coefficients in chemical equations provide mole ratios that can be used as conversion factors. And that conversion factor is that molar ratio, which we're gonna lab after next, we need it.
I think he answered 5.
Yeah, you just answered 5.
Oh,
He answered 5.
that's so funny. No.
Oh,
Oh.
Conversion factor for converting between mass and moles is the molar mass of the substance.
Oh.
That's if you're going from mass to moles. So say you're going from mass to moles to mass, which is what we'll be doing week after next in our
Isn't
lab.
grams per mole technically a ratio?
Yes, well, no, but it is a ratio, but
But it's
we're,
not mole ratio.
we're talking about mole to mole ratio. So if you have 10 moles of substance A and you want to know how many moles of substance B you have, you can use the ratio of, say you have 1 of substance A and 2 of substance B, and you use the molar ratio with the known and unknown, and that's how you get what you need. Oh, I didn't mean to click that. So liquids, in making calculations involving liquids, you must convert volume to mass. And remember, when you're converting volume to mass, you're converting grams and what? What's the volume?
Volume mass, milliliters.
Milliliters, yeah.
Whatever.
Right. And remember when we're doing conversion factors where we can add in the metric stuff, right?
Yeah.
Like you can say there's so and so many grams to a liter, and there are so and so many milliliters to a liter, and then you can cross out liter, right? So to convert from volume to mass, you can use the blank of the substance as a conversion factor.
The density?
When calculating the number of particles, what do you use as a conversion? Yes. Hey, all right, so now in what mass of sulfuric acid is required to neutralize 2.65 grams of potassium hydroxide?
and
Who-
we're doing this in the order.
Yeah.
Yeah,
Got the, huh?
I was just reading the top part.
Oh, yeah, that's just, yeah.
The blank to the left after the letter choice, the best completes the statement.
Mm-hmm.
Ethan, what did you get for 9?
Huh?
What'd you get for number 9? Who has number 9? What's the first thing you do? Yes. Yeah, you have to balance it because if you don't balance it, you can't get your molar ratio, right? And then what should you do before setting up the problem?
You did it.
C, I think.
But A is part of C. So
Yeah.
Okay,
could be.
there you go. You have to know the molar masses. Which, how do you get the molar mass of a substance? What do you do? Yeah, but how do you do that? How do you get it? Where does it come from? Periodic table, right? So if you had H2O, you would look up hydrogen, right? Find out its AMU, and then what do? You multiply it by H2O. So you multiply that AMU by 2, and then you add what?
16.
Yeah, 16, right? Good, Michael. The AMU for oxygen. Perfect. Very good. All right. So how should you check your setup? What do we have here? Yeah. Now it's like, how do you determine the steps? All right, so they want you to say B, yep. Check to see if the results can have the correct units. Remember, when you're setting up, you're always, you know what you're trying for, right? And you know what you're starting with. So you keep using those conversion factors that flip, so you can cancel the units, right, all along, so that you end up with what you need.
This one.
We did
it went
D or D.
I don't know. I could do
D
So,
would have a lot of
What
time
should
in
you
it.
round off?
It
So,
depends on how precise you're trying to be.
Yeah,
Yes.
That's it's a
Right.
different question.
This is
right, depending on how precise you want to be, exactly, but
how accurate you want to be.
how accurate, correct,
That's why we.
accurate. you wanna
But if you round something, you have to round everything.
Right, if you're rounding something, round everything.
Unless
And
it's the last.
usually you
Yeah.
make a decision at the beginning, how many decimal spaces you're gonna go out. And you just kind of stick with that and keep it all the way through. Or if you want to be more accurate, you guys okay? If you want to be more accurate, keep your calculator handy and work it out multiple decimal spaces, right? And then round the final answer. So you're gonna get a more accurate answer if you do it that way rather than rounding all the way through, right? So which of the following is least likely to help you verify the final result?
B.
B.
We did D. Or no, B.
The,
So it says, what did it say? C.
C.
Recheck all the molar masses.
I mean,
Hmm.
these last two are sort of.
Yeah, these are kind of like,
If
but,
you messed up on reading the number on the periodic table.
oh yeah, basically.
It's like, what?
Uh-huh. Did I get that wrong? Or sometimes I've done it and then realized that I missed a subscript or a coefficient and I had the whole thing wrong from the beginning and then it's, you gotta go back.
Just recheck everything.
Right, right. So determine the number of grams of phosphorus formed for each 1 gram. All right, so calcium phosphate used in the production of phosphorus in an electric furnace. So here's our reaction. So I'll put up here what we have. And what did you guys get for an answer? Did you guys get an answer or we still working on this one?
Yeah, we still worked on it. We did the. at the
Okay.
time of That one, we didn't know it, and then we moved on to the homework.
All right, so what they
We figured
did
out
here-
we're doing the homework.
Okay, so yeah, what they did here is they had 1 gram of the calcium phosphate. You see that? And then we're trying to get to the number of grams of phosphorus. So here, right here, do you see this? This right here is the molar ratio that you need. So in order to get that, you start with your grams. Are you following me over there on the couch? Yep, you start with your grams of phosphate. All right, and then calcium phosphate, sorry. You're gonna put that on the bottom as grams. And this is using your what? Where do we get this number?
Molar mass.
That's the molar mass. And you're gonna say that's 1 gram, right?
Right, one more.
Now you can take your grams and you can go, woohoo, where's my annotate? I swear I clicked it. Hang on, make it purple, blue, something. All right, so you can get rid of your grams here, right? Because that's the goal here, is to get rid of the grams. And then you got your 1 mole. Okay, well, if I have a mole, I gotta put a mole on the bottom. And what mole am I putting on the bottom? Look, I can take the whole thing out. See, the whole thing comes out. So now we have 2 moles of phosphorus. And how do we get 2 moles of phosphorus? Well, because this is your equation. Here is your 1 mole of calcium phosphate, and here is your 2 moles of phosphorus. As long as your equation's balanced, that's the ratio you're gonna use, right? And then you got mole of phosphorus. And then what are you gonna put above your mole of phosphorus? What's that? What's that?
Your weight.
What do you do with the 2, even though it's 2
Mhm.
molecules of phosphorus?
Yep,
Because it's PO42.
where are you looking? Oh, right here?
Yeah.
No, you're not worrying about that. You're worrying about this whole thing. How many are
Oh, you
here?
took the molar mass.
1,
Yeah.
right? 1, that's a 1, not 11. I swear I hate this little stupid thing. There you go. All right, and then if you do the math all the way across, this is where you end up. So for the next one, same thing.
Wow.
No, go away.
Well.
All right, here's the next one. So look here at how we did it. Same idea. I'm gonna make that thicker. I hate that stupid little line. Okay, there we go. So we have 18 grams of aluminum. And we wanna know how many grams of aluminum chloride are produced when 18 grams of aluminum are reacted with an excess of hydrochloric acid. Okay, today we had an excess of what? in lab?
Strontium.
Strontium chloride solution, right? Aqueous solution. So we're gonna put our 18 grams here. And we got to get grams of aluminum gone. So here's grams of aluminum. Grams of aluminum. So we're going to put that on the bottom. There's our molar mass again. That's 1 mole. 1 mole is 26.98 grams, right? We want to get rid of moles of aluminum now because we're trying to get to what? We're trying to get to grams of aluminum, right? So in order to get rid of moles of aluminum, we have to use this molar ratio too. So what we're going to do is we're going to take out moles of aluminum and moles of aluminum. And here on top, we have, this is the moles of the aluminum chloride. So how do we get rid of moles of aluminum chloride? Down there. Moles of aluminum chloride, and go all the way across. And you end up with what? Tell me what you end up with. Hello. There you go. 89 grams. Mm-hmm. Oh, geez. Oh, am I not a big enough bed for you? There you go. This dog's ridiculous. All right, so, oh, I gotta clear that. Hang on. Gotta clear it all. Clear all drawings. All right, there we go. So how many grams of ethanol? Yeah, it can be made by fermentation of 1,150 grams of glucose. Did y'all, some of y'all got it?
I got it.
All right, let's see. Alex, what'd you get?
588.15 grams.
588. There you go. Pretty good. Yep. So there was rounding somewhere in there, or not rounding in his case. Perfect. Very, very good. This right here, I might actually see if we can, yeah, there's a lot of it in there, but I might actually see if we can make this work because we have some cider fermenting in the basement and we use a hydrometer to determine the alcohol content, which we're going to do in, it's right before Christmas. It's the last one before our Christmas party. And we're going to be determining the amount of sugar in juice and soda because the hydrometer tests like the density of the fluid with the sugar in it. And then you can figure out how much alcohol the sugar will produce. Now the hydrometer we use has little marks on it. You don't have to do the math. We'll be doing the math.
So you said the lab before Christmas is like figuring out like soda and juice. Can we drink the soda afterwards?
It's flat. I've already made it. So we have very flat root beer. I shook it for like an hour and a half to make sure it was super flat. Because I had to ship some of it, you know, to the girls that live out of state.
Let's drink it. It just, it's flat.
So if we get a good sample of our cider, I'll see if instead of using the hydrometer, well, we'll use the hydrometer, but we'll do the math and see if we can estimate what the ethanol content would be. So the ethanol content for something like cider that you're fermenting, what would that tell you? What would that mean? The ethanol content for, if you're fermenting cider, like we're doing in the basement, what's the ethanol content mean? What's that mean? What's ethanol? Alcohol. So it'll tell you what percentage, you can figure out from that, what percentage alcohol you've got in your cider. That's how, I don't know if you've ever looked on like bottles of wine or beer, it'll say like 5% alcohol or whatever.
Clear like 60%.
Well, okay, so that's another thing. So if you look at distilled spirits, they don't use the percentage, they use the term proof.
Yeah.
And it's basically, it's half. It's divided in half. That's what proof means, but it's the same concept.
So 100% proof would be 50%.
Yes.
No, 200 proof is, yes, okay, yeah. So how many moles of oxygen are required for the combustion of 25.5 grams of magnesium?
0.5 grams, 0.5 grams of oxygen.
Did you get something different, Jack, or what'd you get?
I got something different.
I got something different.
What'd you get, Jack?
I'm pretty sure mine's not right. I had 16.8.
16.8.
Moles.
Not moles, sorry. I can't read my handwriting else either.
You're with me. I can't read mine either if I'm not super careful.
Stuff for granted.
So here's what we have here. All right, so let's look.
I think it's, when it's moles of oxygen, does that mean moles of oxygen molecules or moles of oxygen gas?
Moles of oxygen, the element. So yes, and they are, of course, they do stick together. So it would be O2, but O2 itself would have a molarity of 32, right? 16 and 16.
So it's 1 mole of oxygen gas or 2 moles of oxygen.
Two atoms of oxygen? Is that what you're saying?
Uh,
Oh, I see what you're saying.
Is the moles of oxygen the oxygen in the O2 or O?
O2 would be what you're using. So
You're looking for moles of
Yeah,
O2
yeah.
or moles of O?
I think I understand what you're
It has
asking.
O2 on one side and O on the other side.
2 and 1.
It has-
Oh, I see what you're asking about. Here
Are
to
you
here.
using-
Yeah.
Look at your coefficients. So here's what you're using for your molar. You're looking for O2 because it's asking about how many moles of oxygen are required. Here's your oxygen.
Oh, yeah, so 2 times. whatever.
This one you're worrying about, right?
Yeah.
There. Woo. So you're worrying about this guy, and you got the magnesium here, and yeah. So well, we ended up with that. Go away. Click. 0.525 moles of O2. Does this one make sense, or are you guys still confused on it?
I got it.
I think it makes sense.
Okay, yeah, I think where you were looking is, were you looking at this oxygen here,
No, I was-
or were you looking
Moles of
at?
oxygen. I didn't know if that meant the moles of oxygen, the gas or actually
Okay,
mole atom.
yeah, okay.
Yeah, I thought it was the,
Yeah, exactly.
I thought it was.
Yep. I get it. I get what you did.
It was very confusing.
Yeah. So how many grams of carbon dioxide are produced from the burning of 1 mole of amyl alcohol?
I believe it's 220.0475.
220.0475. There you go.
Let's go.
Very good. 220 or close to that. Do you guys over there, Ethan, Kai, Ivy, are you understanding what's going on? Okay, so, I gotta erase that thing.
0.525. You got 0.5. So, that's right.
All right, so then let's look at this next one then. How many moles of nitromethane are needed to form 500 grams
Oh, we
of
did grams.
chloropicrin?
42.
Oh, yeah, we did grams.
Is that how you pronounce that last name?
That's my guess.
3.04.
Yeah. It's a chemical used in pesticides. So this is what we're starting with.
500 grams.
So you see,
It's not 42 moles.
gotta like your moles, man. So look here, you can get rid of your grams, and you can get rid of your grams. And there's your 1 mole. And you can, obviously, where are you getting this from again?
The AMU.
Yeah,
All
AMU
the
of what?
AMUs added together.
Right. Carbon plus chlorine times 3 plus nitrogen plus
Yeah.
oxygen times 2, right?
Second.
Right. And then, oh, look, here's your mole. Blip, blip, and you go all the way across. Sometimes you're gonna get this 1 mole, 1 mole. Well, I didn't line that up correctly. 1 mole, 1 mole. And that's because, you got 1 here, and then you got 1 here. Remember that when we get to lab.
Yeah.
You may just see that again. 1 mole, 1 mole. All right.
Is it? I did it in grams, but I think it adds up to like
What?
4.
3.0, wait a minute,
Is it like
3.042.
I did it in grams. so-
Okay.
I got 3.041, but.
Okay, that's
Oh my
pretty
gosh,
close.
I was right. I said 42. There's 42 in it.
42 is always in it. All right, so let's look back at Lavoisier for a minute, because I told you there's some interesting stuff about this dude. Abby, does this make more sense to you? Not yet? Okay, I'll help you.
Dude, his wife's hair is crazy.
So yeah, so actually, okay, so do you know why people's hair look like this? Do you know why?
Wigs.
Huh?
Wigs.
Yeah, do you know why they're all wearing wigs?
They look fancy.
What was it? It was a certain trend.
A lot of these folks had syphilis. Yeah, because there were no great antibiotics at the time to fix it, and people were busy, I guess. And a lot of them got syphilis. And yeah, I'm serious. And that's why they're all wearing wigs, because their hair is falling out and whatever else. So it became a thing. Yep. Then it became a fashion statement. And it's funny because if you go to the UK now, their lawyers and judges still put on white wigs to go to the courtroom, which is kind of strange, but they totally do it. It's like, we saw them walking around when we were there. Saw one crossing the street, and I was like, dude, he had the curls and everything,
Yeah.
So Lavoisier.
Go back a second, some brownies.
Yes, you want. Okay, Lavoisier, his wife. I'll give you a second to do that.
ladies and gentlemen, I'm going to have my first ever brownie.
50
Ever.
minutes, this one.
These are the best
Ever.
brownies, but they're
I've had a side child.
Abby, can I try and help you with the?
Yeah, let's finish up what we got here and then we'll see if we can practice some more and maybe see if we can figure out where the gaps are. All right, so Lavoisier, his first wife is Marie-Anne Pauls Lavoisier, and she deserves some serious credit.
But-
She worked alongside, Marie-Anne Pauls Lavoisier. Anyway, she worked alongside him for much of his research. So if it were not for her, Cole, if it were not for her, we'd be lacking a lot. She translated everything that he needed from English into French. She manned his laboratory for him a lot. See, he has these cool pieces of equipment. I love his leg, by the way. Check that out. He's like, stick out the like with the tights and all. Yeah. So here is Lavoisier, and he met a rather unfortunate end, but this is totally worth learning if it'll play. Yep, here we go. All right, let me make sure we can hear. We should be able to hear.
That's good, like.
Matter is a complicated matter. In ancient Greece, Aristotle stated it was made from fire, water.
Listen though,
This
listen.
theory was accepted for 2,000 years, but now we know it's made of more than 100 elements. So how did we change our way to see it?
Good old Lavoisier.
It's 1772, and a Parisian
Yeah,
named Antoine Lavoisier is working to improve the gunpowder. And so he studies how combustion works. At that time, people believed that a fire-like fluid called phlogiston was trapped within all matter, and burning meant setting the phlogiston free. That was why after burning, objects weighted less. Working together with his wife Marie-Anne Pauls, he designed a sealed vessel. Taking careful measurements, they put inside phosphorus and combusted it. The weight of the vessel was the same before and after because nothing had escaped. That was fine. But the matter left inside the vessel after the experiment, it weighted more than it did before. If the phlogiston theory was correct, it should weigh less, unless air wasn't only air. What if air was made of different gases that could join other substances and make them heavier? Lavoisier had heard the experiments of Cavendish, who synthesized water by mixing two different gases he called inflammable air and dephlogisticated air. Lavoisier set himself to confirm Cavendish's findings. He removed the air inside a vessel with a vacuum pump and let both gases flow in. An electric spark ignited the combustion and, voila, water started to form.
That's what happened. to Mark.
Lavoisier proved that water was no longer an element, but a compound made of two elements that he named hydrogen and oxygen. That was a revolution. Air, water. The four classic elements were just combinations of brand new elements that should be identified and described separately. Supported by his wife and scientists who believed him, Lavoisier started that search. They identified 55 elements and found a systematic way to name them. He condensed all his work in the first chemistry textbook ever that contained three simple ideas. Phlogiston doesn't exist, the matter we see is made of elements, and that matter isn't created or destroyed. It merely transforms through chemical reactions. The rest is history.
What?
Wait.
Oh, yeah.
Wait a minute.
Oh, yeah. So wait a minute. What? Reign of Terror, correct. So what happens here at the end? All right, Lavoisier, which, yeah,
Oh.
French Revolution. What was going on in the French Revolution? What was going on in the French Revolution?
They were just randomly killed and anyone that wanted.
Who was in charge?
No one.
Louis?
King Louis, 16th, Marie Antoinette was his wife. No, it's his wife. Yeah. What did what was it like to be a regular French person?
Starving to death on the street?
Yeah, and what did Louis and Marie Antoinette have? Like,
Uh,
like everything,
brioche.
right? Yeah,
Oh,
brioche.
brioche.
Let them eat
Let them
cake.
eat cake.
That whole business. All right, so Reign of Terror, yes, whacking people's heads off in the guillotine on the regular.
So did he have ties to mom?
Lavoisier. So this is a little bit from Gizmodo, but I was going to read to you about what happened to Lavoisier. If you care to check it out, there's a really cool website with a bunch of tutorials on it, and it's called Guillotined Chemistry, and it's a picture of Lavoisier, and then his head gets chopped off at the beginning. It's kind of funny. So
Hey.
Oz. All right. There have been a few famous feuds in science history, but there's only one that left a scientist headless. Unfortunately for all of history, in this case, the better scientist lost. That's politics for you. Antoine Lavoisier is considered by some to be the father of modern chemistry. He is one of the scientists that isolated and identified the element oxygen. He provided evidence for the idea of conservation of mass. He predicted the existence of silicon. He might have done much more if he hadn't been killed at the age of 50 in 1794.
So you could say he was ahead of the game.
Ahead of the game. Some of you have taken a look at the name Lavoisier and the date 1794 and realized exactly what cut short the man's life. He was one of the victims of the famous terror. He was killed publicly by guillotine. Officially, now this is where it gets sad, officially, the reason for his execution was his background as an aristocrat and the fact that he spent time as a tax collector, officially. Although there were plenty of corrupt tax collectors at the time, and for that matter, corrupt aristocrats, Lavoisier was considered to be one of the few conscientious liberals among both aristocratic society and government, and he was aggressively trying to reform the tax system. So, okay, what's the deal? Why'd he get beheaded? Actually, what? Go ahead. I bumped the button.
Yeah, why was his time
no.
cut short?
Matter
Hold on.
is a
Stop.
There you go.
He actually got the chop, not because of his position or his work, but because he made a bad enemy. Jean-Paul Marat was born poor and worked his way into becoming a physician and a scientist. Now, this dude has an ego problem. He applied to be accepted to the Academy of Sciences, of which Lavoisier was an exalted member. Marat was especially interested in animal magnetism. Animal magnetism has been framed as the mesmerization or hypnotism, but at the same time also encompassed idea that certain things possess a unique form of energy and contraptions could be used to study that energy. Think about Ghostbusters, you know, right? Marat said that he could observe this energy, which he called igneous fluid, leaking from heated rocks and, no joke, from the head of Benjamin Franklin. Not only does he have an ego problem, but he sounds a little crazy to me. I mean, he's watching igneous fluid leak from the head of Benjamin Franklin, for real.
What?
Lavoisier was unimpressed and said so publicly, and Marat was humiliated and kept a grudge. As Marat gained power in the revolution, he focused on Lavoisier, circulating pamphlets, decrying his science, his background, and all of his activities. Marat also took up the philosophy that if you can't join him, beat him, leading a movement to dissolve the Academy of Science. Okay, they wouldn't accept him, so we got rid of it. Slowly, he turned his party and the public against Lavoisier. This is like major propaganda, right? Yeah. Just as the revolution began to get seriously dangerous, Marat's death at the hands of, get this, Charlotte Corday, turned him for a time into a martyr. His friends and his allies carried a grudge for him and arrested Lavoisier. A woman assassinated him when he was in the bathtub. I'm not kidding. Like, she came in and assassinated Marat. And this is a great story. If you want to read something really interesting, like, do the Wikipedia dive on this. It's funny. So she kills him in the bathtub, this chick. And then now they're all really mad because he's martyred, right? So Lavoisier wrote to his friends, including Franklin from prison. Wouldn't this be interesting? I like to think that one of the letters included the phrase, remember that nitwit who swore you could see stuff leaking from your head? One day, political sensibilities ignited, and prisoner after prisoner was hauled from their cell, given a brief show trial, and executed. Some stories say, yeah, like, ta-da! Oh, what do you say for yourself? Oh, we don't care. Basically, right? Some stories say that Lavoisier asked to be given time to finish his experiments and was told the revolution has no need for scientists. He was executed and buried in a mass grave. A short time later, public feelings turned again, as they often do, and Marat was condemned while Lavoisier was exonerated. Too late. Lavoisier's widow was given his remaining possessions and a short note admitting that he was executed under false charges. That helps now. Ever since then, Lavoisier has been a symbol of the damage that politics can do to science. So people do bring him up as an analogy sometimes, because here's this guy who was ahead of the game, on the cutting edge. I mean, the father of modern chemistry, and he ticks off this dude by saying to him, "You're crazy and I don't want to listen to your science because it's not science." And the guy's like, "But I have power." Chop.
So let me get this straight. This guy studies combustion. The other guy likes the way animals interact. He's like, I don't like you. It's because of
Yeah.
What?
Uh-huh.
It's like a
That's
cooking show.
biology and then
Whose head is on the chopping block?
Yes.
Lavoisier.
Lavoisier, right? What do you want, Alex?
They're on the cutting.
Cutting edge. Yep. So here are a couple pictures. That one at the bottom left, that is Charlotte Corday assassinating Marat in the bathtub. There is a lot of art of this incident. I can show you. Like, if you go to Google Images, there's a ton of art of this woman coming in and assassinating.
That's a weird looking guy.
Isn't it? It looks like a boot. It's a terrifying. I wouldn't want to get in that bathtub.
There's a head
It's
right
scary.
there.
It's a coffin.
Cool.
Yep. And then the one at the bottom. So the one at the bottom is just the terror. It's the guillotine, the day they're pulling people out of jail and just chopping them up. And then on the right, that's actually the Lavoisier there in the red coat being hauled off to the guillotine to
Bro, that
get
is gotta be the
his
worst like
head chopped
cage
off.
thing to ever put somebody in. There's no roof. Like if you had the right opportunity, you just jump off and run.
Oh, for
Yeah.
real.
It melted into the crowd.
But, like, I'll show you. Hang on, I got it. Stop share. Oh, sorry. I will show you. There are some absolutely fabulous Corday assassinated Marat. Aim. Like,
Yeah.
The guy who's wearing his bathtub had a
where's the
bullying
here it is?
reputation.
Oh my gosh.
It's not funny.
You're so rotten. But see what I mean by lots of pictures? Here you go. Here's
I
one.
think she might have dug up some dirt on him.
Chop, chop in the bathtub. And now she's like, I'm gonna hide by the curtain. And I've cut him up in the bathtub.
Overflowing.
Look at this one. Look at this. They're all mad at her because she got him in the bathtub. So what I do? I just stabbed the guy. It's all good. I don't know. Here he is. Oh, dead in the tub. I love these. These are so hilarious to me. It's like, what a subject. This one, he's in the bathtub with clothes on. I'm not sure why he's in the bathtub with clothes on, but that's that boot-shaped bathtub. What are you doing? There's poor Charlotte in jail. Poor Charlotte going and killing people. Look at that one. Oh, chop, chop, chop. Look at him. He's like, no. And she's
talking about a spooky.
she's tossed a knife into his chest. I mean, look at the funky tub. That is a funky.
If I got in that
That bathtub is pretty sharp.
But I think that's why he couldn't get out, because it's one. You're so bad.
No way.
It's one of those weird tubs.
Wash away the funk, though.
This one is my personal favorite.
Wash away the
I
funk.
love this. He's in the tub doing some work, and she comes in behind him. I saw this one the other day. I was like, that is a great picture. She's like,
That's how I'm gonna kill my husband.
very, very, yeah,
No, I never killed
slightly crazy there. And then, here's all these other ones of him getting chopped up in the tub. This is Marat, by the way, if you wondered what he looked like. He's this dude with the bad hair.
Michael, I think that might be your ancestor.
I think he may have deserved to die for the haircut. But
He doesn't have that freaking nose.
I don't know.
That's a schnauzer.
No wonder you like to watch liquid come out of Benjamin Franklin's head.
I mean, what an idea to say something like that and so confidently claim it. And this is like, I don't understand why all these people are there. They all come to get her, I guess.
It's
But
not a great bathroom.
yeah.
She pulls out 51.
So anyway, it's an interesting fact in history.
Why does every painting from this time, whenever something dramatic happens, it's always like somebody dying dramatically?
Oh, yeah.
A person like this.
It's like Hela from Thor Ragnarok. All the dark just comes in and she just throws it.
And apparently they have him at Madame Tussauds, the wax museum. They have him in a tub,
You finally get the shampoo out of your eyes.
right?
On the cutting edge.
So let me show you this escape room business that we did with the other group so that you can see what it looks like and to try it at home. But then I want to give you guys some time to work on these equations if they're causing you stress. Where did it go? Or did I lose it? Oh, no.
Anyone else want to hear a really bad joke about it?
Yeah.
No.
Yes.
Okay.
I don't.
She forgot why I killed him. It was on the tip of her knife.
Oh, that one's pretty bad.
I know, thank you. My dad taught me all he knows.
Oh my.
I guess she didn't get the point.
Oh.
Oh, I got that. I was funny.
All right, so what I'll be sending you, listen up, what I'll be sending you is a link and a code. All right, and this is the link in the code. And when you get here and you, whoops, hang on. You get the link in the code, you're gonna have to enter your name. And if you, it will give you a code at the very end if you get all the way through it. And I will give prizes for anybody who comes back with the code.
Group thing, should
I mean, you,
send it to my Discord group
you
chat?
can't, y'all could, but it's kind of like one person can't move on. Like you have to do it either as a group or as one. I'll show you what I mean. So if we put ourselves in here and this is our team, all right, and it will show me, guys, it will give me information on when you put your name in, it'll tell me who's logged in, you know, how far you got, what your answers were. So I mean, I can see all of it. Yeah, whatever you put in
I
there.
guess Lavoisier was
So-
head over heels about his
Oh
work.
my word. Okay. So it starts like this. You're in the room. Okay. Your first room is just putting in the code and your name. Your second room starts asking you questions. And this first one's an easy one. So it talks about law of conservation of mass and gives you an example of an atom and an element. And then it says, because all matter is composed of atoms, another way to state the law of conservation of mass would say that the atoms that are present before a chemical reaction must be exactly equal to the blank present at the end of a reaction. So your answer would be atoms. So this you have to pay attention to this right here. This last line at the bottom of every page tells you exactly how to enter your answer. For example, there's one where you have to put in coefficients, but it tells you that you have to put the coefficients in numerical order from greatest to least or whatever. So if you look at an equation and your coefficients are 1, 1, 2, 4, then you have to go back and put it 4, 4, 2, 1. So it's partly like paying attention. So you say atoms is your answer, you put in atoms, then you have to hit this button that says next, and it'll take you to the next room if you made it through. If you didn't make it through, and this whole next one is about Lavoisier, and it gives you a link to read, but we just learned about him, so we might know it. Yes, Jack?
Okay, one, is this required?
No.
And then two, I have another joke.
One more.
Okay.
Yes,
No.
yes.
No.
What was the guy who
No.
got assassinated? His name?
Lavoisier? No, Marat
Marat.
or Lavoisier. They were both.
Marat didn't hate Lavoisier. No, okay, hold on. No, I
He's
got
really working hard.
Quiet.
I've been thinking about this for a full 3 minutes.
Oh my word. I'm worried now.
Remember when Joe Namath guaranteed a Super Bowl? He's like, I don't guarantee you will,
No, but I believe you.
Okay, so he's like, so Marat didn't hate Lavoisier's work, he guillotined it.
Oh my word. Okay, that was
I really tried.
that was the bad one, but all right, there you go.
Alex, fix it for me.
All right.
Make it better, please.
All right. How old was Lavoisier when he died?
38.
Who remembers? 51, 61, 50, or 60? 50. So look here. To create the unlock code for the next step, you must put the letters of the correct answers above in order, uppercase only, no spaces. So the answer was C. So you put C. All right. Now what's the next one? Y'all tell me.
Wait, what is it?
D.
Don't scream.
Question mark.
They didn't create.
D.
Yeah. it's D.
I wish I could put.
CD.
Okay. What's the
Once
next
you died,
one?
A.
No, run number 3. Before Lavoisier.
Oh,
Oh,
A.
Yeah,
Which
it's A.
one?
I can't remember how to say this thing.
A.
No, they didn't
Well, I
have
just
a
did.
fire. They always left, it was what was left
They thought it
over.
was released by fire.
Okay, what's the next one? How did his wife help him with his scientific research? Well, it was mostly the translating. That's directly from that article that's attached. It talks about that specifically. Okay,
A.
A. All right, so if you have this right, when you enter here, it will take you to
You
the
rolled
next
off
one.
the
See?
stage.
All right, so now what I want to do is I want to No,
Go to your.
put up.
He was a,
Feel good for myself, right?
I'm
Where's
not
that
one.
board, huh? What?
Marat's murderer was normally a knife person.
Oh my gracious, y'all gotta quit. Where's my board? Whiteboard, whiteboard. I can't remember where to find it.
Marat was a
Is there a whiteboard here? Where is it?
You have to stop sharing.
Oh, that's it. Thank you. There, you reminded me. I'm like, where is it? It should be here. Ooh. Wait. Is it under here? There it is. There it is. Thank you. Gosh, I'm losing my mind. All right, I'm gonna write one for you. Mom, will it let me take it off? No, of course it will. Yes, it will. All right, good. All right, so this question is, how many moles of H2SO4 will react with 18 moles of aluminum? So I'll write that out. How many moles of H2SO4
Take it outside. I don't want.
you won't let me erase.
I'm so tall.
It makes me nuts.
All I had to say.
Ah,
You have literally every event.
Not to mention, my dad doesn't like people like fighting on the couch, so.
You are,
all right, here's the equation.
Yeah, and he comes down
Okay.
I mean, there's 9-mile bike ride. I mean, there's a roundhouse. He just gets overhead. Yeah.
Just let him boil it.
Y'all writing it down? Up. Hello. Come back.
It's 2 hours. That's all
Hello.
Pretty fair.
Right. Let's see who can come up with the answer for me.
So how many moles of
27.
will react?
Brother.
Is it actually 27?
It's 42.
I'm giving everybody a chance to work it.
I got that.
5.04.
Did you tell me the ring or did you just guess?
No, I didn't.
Let me use my big brain to figure this out. I can sure it's.
Is it 5.04? I didn't do any of the work I was
No, it's not 5.04.
42.
42 is always the answer.
Guys, I don't see 15.
Hang on, people are actually working. Let people work through it. Where are you looking? 18 moles of aluminum, AL. Yep.
Yeah.
Okay.
I need like all of these things.
Yeah, I know.
So what's the first thing we're starting with?
18.
What do we know? 18 moles of what? Aluminum.
Yes.
That's not how it's.
All right. How do we get rid of 18 moles of aluminum? We got to put 1 mole of aluminum down here, right?
Yeah. Yeah.
That is 26.98.
We're gonna. That's what goes above it. What is it, Cole? Cole, what's 27?
Yeah.
27 gram. Is that what you just said to me?
Why are you converting it into grams?
Moles. 27 moles per gram. Here's our 1 mole. What's next? Somebody tell me what. Alex, do you want to do it? You want to write it on here?
You're gonna need to.
Here, you do it.
I think I work
working on it.
I think you're going to need to convert.
Take the stylus, it's much easier to write with. There you go.
You're gonna need to convert from moles of aluminum to moles of sulfate.
All right, so go ahead. So Alex is working it now. See what.
Alex is on TV.
Oh, really?
There's Alex's note. It's fluffy.
Hi, Alex.
I don't know which one to
Hi,
click.
people.
Let's just say that one. I don't know. Yes.
All right, so explain what you're doing as you do it.
I'm using the mole ratio to figure out how many moles of
Okay.
hydrogen sulfate are.
Okay. So you're doing
Yeah.
2 mole. Okay, you've got the mole ratio here right away.
He's doing the work in his head.
Not you, Miss Sandy.
She just hates me because I'm making hilarious dad jokes.
Dude, dad jokes are fun.
Dude, that, you
Just
just have
ask
to
Jack.
appreciate them.
Jack knows all about dad jokes.
You have
My
to
dad
appreciate
taught
dad
me
jokes for what they
everything
are.
he
They are
knows, and
very
it pains me
well
every time I say
they're
one.
hilarious.
Stop talking.
You could say he's doing the work in his head.
Wait, I thought I clicked eraser.
Oh, Ethan.
Oh, Ethan.
We sat it. Where was it? Was it Roadhouse, Texas Roadhouse one night and looked up bad pickup lines. That was equally as funny as that.
No, it was pickup.
Are you from Tennessee? Because you're
Pickup
the only
lines. Some of them are
Tennessee.
great. Just great.
Did you Lucky Charms
Are you an artist? Because I'm drawn to you.
All of
Do
them.
you Lucky Charms
because I'm
for
drawn to
breakfast?
you.
Yeah, my handwriting's bad, but that's 3 moles of H2SO4.
Okay.
And then you multiply 18 by that.
My cousin literally showed me a full video,
Well,
an
you can
hour-long
cross out.
video of pickup lines.
That you
I
get
don't know why he
18.
does these things. He likes your mama jokes and pickup lines, and that's
Your mama
basically
jokes are
what.
literally
Ethan,
like,
this
they're
is
not
one of my
even
favorite
jokes,
pickup
they're
lines.
just
Ethan,
I don't mind them as long as my
do
kids
you
aren't
believe
telling
in
them
love
to
at
each other.
first sight, or should I walk past you again?
So,
That was
There's
funny.
one more,
That was
but
pretty
like,
good.
I can't even say it because it's so.
would anybody ever use that? No, but it's
Are you
yeah.
okay? Because I really want to turn that page. That was the worst one he showed me, and I'm like,
What is it?
no. I'm like, why? I'm like, this is an hour-long video for what purpose?
Oh, I have
How is
something.
there an hour of
Don't leave.
friggin' pickup
So, like,
lines?
It might not have been an hour. I think I made a
found, like,
playlist
it's
of
one of
them.
those-
You can make YouTube playlists.
There you go.
And I'm like,
So I ordered a
you
couple
realize
things. I'm like,
this
"Gee,
is an
China
hour of
stuff,
my
I'll
life.
try it."
I'm never
And
gonna
I
get
did,
back.
And it was a
But at least
sweatshirt
you
that
can
would've
pick
been
He's
up
like,
girl.
but it's so
black
worth it.
sweatshirt,
And I'm
I
like,
pulled it out of the box and I was
first
like,
of all,
"Is this ties?" Because I'm not
look at
wearing
me.
this.
Girls
I
will
wear
never
this.
be
Like, it looks
attracted
like
to
something
me.
you'd wear.
I will
And
wear it.
two,
Yeah, I'll give it to you before you leave. Because I pulled it out, I was like, "Oh, this isn't."
none of these pickup lines will
Oh, this is
I didn't
ever
think it was a
work.
tiny one.
And
And he's
It's
like,
tie-dye
you watch.
kind of, but dark colors.
I'm gonna get a girl for this. I'm like, I will bet you
That's why
$50
we're
of
like-
imaginary
I pulled it out
monopoly
of the
money.
box, so I was like,
That
"Oh."
There you
will
go.
not get a girl for this.
All right, so he got it.
27 moles of SO4.
All right. Okay, so explain to Abby. Wait a minute, y'all. Shh, shh, shh. Alex, explain to Abby as clearly as you can
Yes.
why you made the choices you made and how you got that answer.
Why did you make those choices, my guy?
Tell me.
Why did you make those choices? Shh.
Let him talk so that Abby can listen.
Tell me
Make
when
sure
you
people
want to
understand.
Shh.
All right, so you started with 18 moles of aluminum. So
Yes.
that's what you knew.
You then need to convert
I
to
don't feel safe.
moles of H2SO4. You
Right.
didn't actually need to convert in and out of grams because you already had it in
Right.
moles. You
Right.
didn't need to convert it afterwards into grams because you were looking for
Looking
moles.
for moles.
So
Right.
it's really just you multiply it by the mole ratio,
I knew
which
that.
in this case is 3 moles of H2SO4 for every 2 moles of aluminum.
I could have
Good
given you
deal.
that answer.
All right. Does that make sense? Oh, we have one. Okay, wait, it's clicking, so let's do one more. Do you see how to erase that, Alex?
Hit eraser and then just
Or there's a, if you go up there and click, there's one that says clear. You see the one that says clear?
The
It's
trash
trash
can.
can. And then clear all. Good. All right.
ta-da!
Pass it over to Michael or Cole or somebody who's confident with it.
Cole.
No, I'm not confident.
Okay, Jack.
No.
Actually, bring it here first so I can write down the equation. And so I don't have to read it to you because that gets ridiculous.
Yeah, that'd be bad.
Yeah, that'd be ridiculous. Okay, let me see.
All right. You have to. I'm gonna eat
my brownie, and I'm not.
Stop moving. Yeah, y'all don't yell so much. All right, which one do I want to use? Which one do I want to use? All right. 2Na solid plus 2 H2O liquid. Oh, keep doing that.
You're dead and your body's in pieces.
Hello. Come back.
I said I will never. You would have to rip me apart.
Good, diggity dog.
Because it's already really hopped up on
I
sugar.
keep tapping it.
Well, rip you apart, no, kill you probably.
Come on.
So I'm wondering who I'm sitting next to, and I'm really trying to grab away.
Hey, Cole, y'all are too loud.
Yeah, Cole, shut up.
Yeah, I know you live here, but geez. All right, yields 2NaOH aqueous plus H2 gas. All right, and I want to know how, come on, how many moles of sodium will react with water to produce 4.0 moles of hydrogen? How many moles of Na2? Okay. To produce, how many? 4.0.
I'll move it since it's-
Man, it keeps doing that to me.
No, I'm not gonna get higher. It's just gonna get.
Okay, how many moles of sodium to produce 4.0 moles of hydrogen?
Hey guys, welcome to my PowerPoint presentation.
Use sodium?
Beautiful light fixture, dude. Yeah. That's good, dude.
Alright, Na sodium 22,
Is that-
23,
How many? How? But it's HAO?
23.
That's not how you say it. Did you? Where's my phone? What happened to it?
Which Na do you
Yeah, we
need?
got moles to moles. What do we have? How many
Sodium,
moles
okay,
of
sodium
1Na to produce 4 moles of hydrogen?
Oh, we're going moles to moles.
Yeah,
So we
Okay.
don't need
yeah.
any AMU.
So 4 moles of hydrogen
What?
over here.
Yeah. Yeah, I'm fine. Yeah.
I need to put your team filter.
They still
Okay.
function the same way. Like, they don't-
And then, it's time for,
Hey bro, what just
How
happened?
many
to
moles?
TV?
what in the world?
It's not me. Oh, I'm just. Yeah, I'm just too far away.
Come on, Mike. It is you.
I
It
was,
is
I was
you.
gonna use the tape.
Get it together, Mikey.
I can't.
I know your family members call you Mikey. I've heard of that.
Yeah, some of
My
them
Hazel calls you Mikey. It's so
Yeah.
cute.
Aw.
Super cute.
I really did.
I don't want to.
For a full second and a half.
All right, somebody note the time. What time is it right now?
The time is now, 1:24.
Okay, so I am putting these in. So around 1:30 tomorrow, 1:25, somewhere like that, and I'm going out. And you should get a message from somebody for that.
Oh, okay, you know better now?
Okay, 24 hours.
So 1 of 4 moles of hydrogen. It's 2
Alex, what sugar is about to say normally?
Thank you.
Isn't it 8?
Depends
You think I have
Well, what does
house,
H2 mean?
went around
No, we only need the
Yeah.
coefficient.
And I don't.
So it's 2.
Great, look at this, he's moving along.
His legs are like.
I didn't want to sit down.
I had to switch you around.
Miss Danny, if I pour 2, marshmallows.
You pour two what?
Eight, maybe nine.
Hey Cole, can you put the chairs out for Jackie's
Yeah,
table, please?
maybe you were pushing it around.
You're taller than me.
They're making fun of me for being short. Therefore, they're.
You are taller than me, are you not? Aren't you taller than me? Everybody's taller than me. Like everybody except you. Everybody's taller than me. I am. Have you ever had to climb the shelves in Walmart? Because I have.
Oh my god.
It's classy when you start climbing the shelves.
There you go. It's 8 moles of an egg.
8 moles. Michael gets it right. 8 moles of soda. Nicely done, friends. Okie dokie.
I'm so sweet.
So for your homework, it's in Teacher Ease. I'll put it in the
Gorgeous.
email. Ignore what's in the binder. Watch the video. Take notes.
No.
You kind of look like a funny raccoon.
I never did that way.
It kind of looks like you could shave it and it looks like.
At least I don't look like a lump.
You would,
Thank you, Michael.
you would be the only one.
Right.
You kind of look like knockoff hair.
So like, do you think that Michael's the only one who's clouded pull off his lip?
Oh, I don't know. Ethan would look pretty good.
I was gonna say, you think we do.
Cole tried it during the Corona thing, but he didn't mean to. He didn't mean to. He just couldn't. All right, bye guys.
It was so bad.
I did.
Your moment